Hey, physical science kids, Mr. Tima here. Going to do a little different view of your notes, but that's okay. It'll be easier for you to see the stuff I'm trying to teach you anyway. But here we go. So you should have watched this video already. What's the size of an atom, or what really is the size of an atom? So make sure you watch. That's about 5 minutes. Ed puzzle right before this. All right. But what is an atom? An atom is a nucleus that has protons and neutrons in it and surrounded by electrons in what we call orbits and shells. And this would technically be called a Bohr model here. And we'll talk about what a Bohr model is, and we'll keep talking about that as we practice that later on. Okay. But again, inside an atom, we have protons, neutrons, and electrons. And you'll notice in science, we don't like write proton, neutron, and electron on there. What we do is we end up giving them symbols. Okay, and you can either use an N for neutron or you can use an equal sign because we tend to talk about them in their charges. So for example, a proton has a positive charge and we say it has like a mass of 1. A neutron has no charge or is neutral, and it has also a mass of 1. They're almost exactly the same size as a proton. All right, electrons have a negative charge, and I always think of like electrons as electricity. Okay. And if the electricity shocks you, you're having a negative day. And we actually say it has a mass of nil because if you're a soccer fan, you know nil means 0, but it means the game was played, though. We don't just say 0. But when we do math, yes, we just put a 0 in there. But we tend to say nil. It's so incredibly small, we don't worry about it. It's kind of like if you were on a jumbo jet flying out somewhere and someone flipped you a penny before you got on the plane for good luck, you would not in any way, be worried about the mass of that penny as compared to mass of other stuff to make sure that you got off the ground. And if you notice here to the left, you'll see that for the proton, I have a blue with a plus sign, a yellow with an equal sign, and a red with a negative sign to kind of help you visualize these things. And if we were in class, I would use the board for that. And I'll probably pull them out, but hopefully for this, it will help you understand. So first of all, atomic structure. This is called the script form. Okay, this is called the script form. And what that means is we write the atomic symbol of an element. So this element, does anybody know? Helium. It's helium, and it has an atomic mass of 4 and an atomic number of 2. Now, if you look up at the periodic table, it's going to say like 4.002. That's the average atomic mass, and we'll get into what that is. But for right now, we're just going to say it has 4. We're going to round it to 4. Okay, and what that means is the atomic mass is made up of protons and neutrons. Okay, while the atomic number, or its identification number, this is specific only to helium, has 2 protons, because protons are kind of like the identification number of an atom. Okay, so helium always, no matter what, has 2 protons. Okay, it's always going to have 2 protons, no matter what isotope it is, and that's a word that you're going to learn about later and everything. And it's always going to have 2 of them, okay? But it has a mass of 4. Well, as you get more familiar with this and stuff, if the entire mass is 4, which is protons and neutrons, and you know from the number 2, or the atomic number, that 2 of those have to be protons because of the atomic number, then the other 2 have to be neutrons. And if you look at them together, the total 1, 2, 3, 4. Okay? So for example, again, if this was 2, it has 2 protons, but it has a mass of 4. Now, I can't bring an electron down here because even if I put this electron down here, the mass would still be 4 because it's like 1 plus 1 plus 1 plus 1 plus nil or 0. We don't worry about this guy. Okay, there are electrons in this atom, but we don't worry about it when it comes to the mass. And something Mr. Gannon always told me was, as another teacher in the building, is that your atomic number is like your age, and your mass is like your weight. And no matter how old you've ever been, your weight is always the bigger number compared to your your number, which is your age. So your age is always less than your weight, or your weight's always more than your age, okay? Because even when you were born, you were like 10 pounds, okay? But you weren't even 1 year old yet. This is very important here, and this is going to become very important as we move through very quickly. In a stable atom, and as of right now, every atom that you know of is stable, the number of electrons is equal to the number of protons. So right here in this atom, how many electrons would there be? Hopefully you are answering 2, okay? Because if you know there's 2 protons, then there better be 2 electrons. And if you added all this up one more time, you would still see 1 plus 1 plus 1 plus 1 equals 4 plus 0, which is still 4. Okay? All right, well, there are 3 ways that we can write it because, science has to be a little complicated. Script form, which is exactly what was on the other slide. This is the script form. Okay? But notice, when we look at a periodic table, you're not going to see it like this. You're going to see it like this, okay? And this is what we call a periodic table form or the periodic tile form. And they just flip the numbers. But again, if you remember, your age is always less than your weight, okay? You're going to remember that this is the atomic number and this is the atomic mass number. And notice there's the average atomic mass. And again, we'll get into that more as we get going, okay? And then here is the isotope. Oh, misspelled it there. Isotope notation, okay, which is what we do is we just write He for helium dash and we put the mass number. Really, it makes a lot of sense because helium always has 2 protons. So we don't really need to write that every time because we know that helium has 2. So just by writing He-4, we actually know it should look like this, okay? So again, we'll get going on that as we get going. All right. So atomic energy levels and shells. Niels Bohr said this. He said that the first shell can only hold 2, and then the second shell can only hold 8, and then the third shell can only hold 8, and then 8, and then 8 as we're all concerned of right now. So first of all, let's try to make the lithium atom with these things. Let's see if we can do it. We're gonna talk about electrons. So first of all, how many protons does this have? And the answer is 3 because we look down here at the atomic number which says 3, and we know that that atomic number means that it has 3 protons. Okay? Well, it has a mass of 7. Well, if 3 of them are protons and we're not worried about the mass of electrons, then we know that there has to be 1, 2, 3, 4. 4 of them have to be neutrons. So I always kind of like to do it like this. I put them right next to each other. If I was on the board, I'd be putting these on the board. I have stickers just like this, and they're exactly the same color. Okay? And that's a good practice, is just trying to make sure that, oh, I'm moving everything here. We'll put that up there. All right? And it looks like that right there. Okay? Now, if we remember back on this slide right here, for every number of electrons, there's equal number of protons. Or for every proton, there's an electron. So how many protons are there? Well, there's 3. So I know that I need to worry about 1, 2, 3 electrons. Okay? So I'm going to come down here. I'm going to put my 3 electrons. And if you're doing math, and some of you are pretty good at math, you could sit there and start doing the math real quick to check the answer. For every proton's worth 1, every neutron's 1, and every electron's 0. So 1, 2, 3, 4, 5, 6, 7. Boom. 3 of them are protons, and we have 3 electrons, but these are all worth 0 in the mass. So 1, 2, 3, 4, 5, 6, 7. 3 zeros is 0, right? So again, we're good. But how many of these electrons fit in the first shell? Well, that'd be 2. We'd put 2 in the first shell. Okay, so pretend it's like a little house, and there's only 2 bedrooms on the first floor. Okay, and then you got 8 bedrooms on the second floor. Well, that means 2 people get to sleep on the first floor, And then this guy gets to sleep all by himself on the second floor in one of the 8 bedrooms. But we got room for 7 more people up here before we move to the 3rd floor of our house. Here's how this looks in real life, okay? So right here's lithium. If you notice, the protons, neutrons, and neutrons are in the middle there dancing around. That's your blue and yellow. But your red, the electrons, here we go. There's our people on the 1st floor, and there's our guy on the 2nd floor. Okay, and he's got room. There's 7 other bedrooms up here, right? Here's fluorine. It has 9 protons, which means it has 9 electrons. 2 in the 1st, and there are 7 in the 2nd. And there's actually room for 1 more person to get up here on the 2nd floor. And then we'd have to open up the 3rd floor, okay? So there's 2 ways that we talk about this in science. One is called electron configuration, and one is called the Bohr model cross diagram, okay? We're going to go through this quickly, but then I'm going to have extra videos to help you understand this. So electron configuration is just like the accounting way or the numerical way of doing it. So nitrogen, if we looked up at the periodic table, nitrogen would have 7 protons. The mass number really doesn't matter right now because we're worried about electrons. So if we have 7 protons, that means we have 7 electrons. 2 in the 1st shell, and then there's how many people left over? 5. So we put 5 in the 2nd shell for a total of 7. You always know if you're right because these 2 numbers better add up to 7. So how would we really write that? We'd literally write 2, 5. Of my 7 guests, I have 2 on the 1st floor because that's all it can hold. And then we have 5 people left over, so we have to put them on the 2nd floor. If there was more than 8, I'll show you what we do in the next one, okay? So let's try to practice this real quick. Let's just try to practice this bad boy real quick. All right. So for example, calcium. Calcium has 20 protons. Okay. So if it has 20 protons, all right, that equals 20 electrons. Okay. 20 electrons. And I like to do this little E with a minus. Okay. So if there's 20 people coming over to your house to spend the night, we can put 2 in the 1st floor. When there's 2 people in the 1st floor, that means we got 18 other people to get to sleep. Well, the 2nd floor of your house can hold 8. Well, do we have 8? Yeah, we have 18. So we're going to put those 8 people left, and we're down to 10 people. Okay? We go to the 3rd floor of your house. It has 8 bedrooms because remember, the next shell can hold 8 too. So now we only have 2 people left to worry about. We go up to the 4th floor of your house. You got a nice house. 4th floor can still hold 8 people, but you don't have 8 people. You only have 2 people. So we're going to let those 2 people live up on that 4th floor, or sleep, not live, sleep. I guess you got good friends, they can live at your house. But there you go. So the actual electron configuration is 2, 8, 8, 2. Okay? And if you add that up, that's 10, 18, 20. We know we're right. Look at sodium. Look at sodium. Sodium has 11 protons. That means we have 11 electrons. We are just ignoring this number right now. We don't even care about the mass because we're talking about electrons, and that's based on the number of protons. So how many fit on the 1st floor? 2. Right here. Only 2 people can sleep on the 1st floor. So now from 11, we're down to 9 people. Okay? Well, now we go up to the 2nd floor. It can hold 8. So we put 8 people on that floor. Well, now we're down to 1 person. Okay, now we're down to 1 person. All right. Well, there are 8 bedrooms on the 3rd floor, but we only got 1 person, so we're only going to let 1 person sleep up there. 2, 8 is 10 plus 1 is 11. Again, you should notice this pattern. And again, I'll work some more of these out on an example in another video next to the worksheet that's going to be about this, okay? But if you want to practice these on your own, feel free or ask me to put one up when we're in class. I'll be happy to do that. All right? Okay. Niels Bohr, he's the guy that did all this, okay? Niels Bohr was the guy that said, hey, things orbit in shells like planets orbiting around the sun. Okay, so he's the guy that said 2 in the first. Well, hydrogen only has 1 proton, so it has 1 electron. I mean, that looks like the moon going around the Earth, if the Earth was made of green cheese, apparently. All right, but there you go. So there's that. Well, I mean, we can go up to fluorine again. Again, fluorine has 9 protons, so it has 9 electrons. 2 people in the first shell, 7 people left over with room for 1 more. And if we got to 1 more, then another shell would appear. Okay? Now, if you can do this the math way, then what we call the cross diagram or the Bohr model diagram should be super easy. Okay? It's the same exact thing. We literally, if you're good at the electron configuration, you can just quickly go, okay, 7. How many fit on the first floor? Well, that's 2. Okay, well, how many people can fit on my second floor? Well, that's 8. But my 7, since I took 2 people out, are down to 5. Okay, there's 8 bedrooms on the second floor, but I can only fit 5. So 2 comma 5. Well, let's look. 1, 2. This floor is filled. We got to move out. 1, 2, 3, 4, 5. With room for, there's room for 3 more people. So if you got 3 more friends, you can come on over, which is really important for bonding and stuff when we get to that, guys and gals. All right. So here's some examples. Oxygen. Again, oxygen has 8 protons. And we're getting this off the periodic table. 8 protons. So if we did the electron configuration, 2, comma, 6. Okay, 2 on the first floor, 8 possible, but we only have, after 2 go away, right? That goes to 6. Okay, 2 comma 6. Let's check it out. 1, 2, 3, 4, 5. I'm sorry, 1, 2, 1, 2, 3, 4, 5, 6. See if you can do the electron configuration for this bad boy right here. Remember, which number are we looking at? Age is always less than our mass. So we're not worried about mass right now. We're only worried about our age, if you will. 17 protons. 17 protons means 17 electrons. So 17. How many can fit on the first floor? 2. So I'm going to write 2 up here. 2. That means we have 15 left over. Okay. How many can fit on the second floor? 8. Well, we have 15. We can fit 8 people up there. Sure. Why not? Now we're left with, simple math, 7. The third floor can hold 8, but we only got 7 friends. So all 7 will fit there. 2, 8, 7. If you check this out, 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. That's full. And then 1, 2, 3, 4, 5, 6, 7 for a total of 17. And look at this. We got 1 empty bedroom. Okay, we got 1 empty bedroom. So if we had another friend come over, there would be room. And again, that's very important for bonding and stuff like that as we get going. I don't want to waste any more time. You're going to have some homework. You'll see these worksheets. They will be Kami files or blue puzzle pieces or green puzzle pieces, and I'll put some extra help on there to help you out. Other than that, thank you for being patient. I know it was a little long video, and if you have questions, please reach out. All right, talk to you later. Mr. Tima out.